Hello students. In this lecture we will learn more about the code optimization techniques. I hope that you already have gone through the intermediate code generation and the basic code optimization techniques. For example, the code optimization, which are machine independent and machine dependent optimizations, before entering into this lecture. So in this lecture we will be discussing about the basic blocks, and if you have already gone through the intermediate code generation, you must be knowing that every loop is converted in the form of the if-else statements. For example, if there is a loop, so we are applying the conditional and the unconditional jumps to pretend it like the loops. So this is done with the 3-address code conversion of the loop in the intermediate code generation phase. It means while entering to the code optimization phase, which is coming after the intermediate code generation phase, we do not have any loop. But what we have seen in the earlier lectures of the code optimization, that we require the loop optimization techniques. So in case we require the loop optimization techniques, we must have an idea about the loops. And in the intermediate code generation, we do not have any loop because we have converted all the loops to the with the help of the 3-address code statements in the if then else form. Fine. So we'll be understanding what the basic block is in this lecture and how do we identify the loops based on the basic blocks. Now see, the high level language code is getting converted into the intermediate code generation or intermediate codes. All the loops are converted to the 3-address codes, and then we perform the code optimization. So before doing the code optimization, you only have the 3-address codes, and which do not actually signify the loops as such. In order to do the loop optimization, we need to detect the loop. Obviously, since in the 3-address code we do not have the loops, we have converted all the loops to the 3-address codes using the conditional or unconditional jumps. So we need to detect the loop in the 3-address codes that we have written. For detecting the loop, we use the control flow analysis using the program flow graph. It means if we have to detect the loop, then we will have to perform the operation of control flow analysis. And this control flow analysis is done on the program flow graph. What is the program flow graph? We will have to find out the basic blocks, and that we will have to find out from which basic block where is the movement to which basic block. It means there is a movement of basic block to the basic block in a code, and this is actually the program flow graph that we define. This program flow graph will contain some basic blocks, and we will be performing the control flow analysis on the basic blocks or the program flow graph that we have found. And based on that control flow analysis, we will be identifying if there is any loop. So whatever basic block and whatever program flow graph we have found, we will be identifying with the help of the control flow analysis if there is any cycle or not. Any cycle found in the program flow graph will actually signify a loop. Now what is the basic block? Basic block is actually the elementary component in the program flow graph that we have to study. So in the basic block is a sequence of 3-address codes where control enters at the beginning and leaves at the end without any jump or the halt. It means the line of codes that we are writing, it will enter at one end and there will be an exit from the other end, and inside the basic block there will be no jump statement. So there will be neither a conditional jump nor an unconditional jump inside the block. So basic block actually is the sequence of the 3-address code statements. Now what is the program flow graph? Once we have already computed the basic block, let's say in the diagram it shows that it has 4 basic blocks: B1, B2, B3 and B4. So program flow graph is actually telling you how the program is flowing. From B1 block we are going to B2 block, from B2 block we are going to either the B3 block or B4 block. So it may be a conditional jump. Okay, so at one place we have a conditional jump, at another place we have the conditional jump. It means if the condition is true, we are moving to some part, and if the condition is false, we are moving to another part. Okay, so control flow analysis is done on the program flow graph just to identify if there is any cycle, and in case there is a cycle, it signifies the loop. For example, in the given basic block and the program flow graph. So first, once again, understand what the program flow graph is. The program flow graph is actually combination of the basic blocks. Here B1, B2, B3, B4 are the basic blocks, and the program flow graph means where the program flows from which basic block to the which basic block. So we have the directions also shown. Okay, from, let's say we are at B2 block. So from B2 block we can either move to B3 block or to the B4 block. Let's say if the condition is true, we are moving to the B3 block, and if the condition is false, we are moving to B4 block. And now if you see, there is a movement from B3 block to B2 block. So if you simply see B2, B3, B2 is a cycle, so this will be a loop. So we are actually performing the control flow analysis on the program flow graph just to identify if there is any cycle in the program flow graph. Now how do we find the basic block? So there are certain rules for finding out the basic block. So in order to find the basic block, we need to find out the leaders. So first understand what the leaders are. Leaders means the statements which is written in our 3-headers code statements. We will be finding some of the statement as the leaders, or we will be signifying some of the statement as a leader. So there are some rules for finding out the leader. So what is that rule? That a basic block will start from one leader and it will go to the next leader excluding the leader. So we are not telling about the leader, it is about finding out the basic block. In the next slide we will be understanding how we actually find out the leader. So let's say we have already identified the leaders. So there are some leader, there is one leader at line number 1 and there is one leader as line number 10. Now the basic block will be statements from leader to the next leader, but excluding that leader, excluding the next leader. For example, leader statement number 1 is a leader, statement number 10 is a leader. So the basic block will be from 1 to 9. So a basic block will start from one leader to the next leader, but excluding the next leader. So 1 is the leader, 10 is the leader. So 1 to 9 statement is the first basic block. Okay, so from first leader to the second leader, but we are not including the second leader in the basic block. So the basic block is one statement above the next leader. Okay. Now, how do we find out the leader? So there are some rules for finding out the leader. These are very basic rules. The first statement in the high level language code, first statement in the 3-address code is always a leader. A statement that is the target of conditional or unconditional jump, unconditional statement is a leader. For example, if I am saying that if x is greater than 10, go to 100. So go to 100 means 100 is a label. So the statement at label number 100 is a leader. There is an unconditional jump, for example, go to 200. So we have to move to label number 200. So the statement written at 200 level is a leader. So any target of either the conditional jump or the unconditional jump will certainly be a leader. Okay, and the third rule is a statement that follows the conditional or unconditional statement is also a leader. For example, at label number 10 there is a statement which is a condition. For example, if x is greater than 10, then go to 100. So at level 10 this statement is written. So obviously this is a this is a statement. So the statement which is written next to this means the statement at level number 11, this will become a leader. Fine. So any statement which is a conditional statement, just next to that will be a leader. So a statement, for example, here at 10 number line or 10 number label there is a conditional statement. So 11 number line or 11 number statement will automatically become a leader. Similarly, if there is an unconditional jump, go to 200, the next example. So let's say at label number 21 there is a statement, go to 200. So automatically next line will become a leader. So 22 line or whatever statement is written at the 22 label will become a leader. So there are three rules for identifying the leaders. First statement in the program will be a leader. Any target of conditional or unconditional jump or unconditional statement will be a leader. And the third statement is the statement that follows the conditional or unconditional statement will be a leader. Now consider a program. This program is about finding out the factorial of the given number. So in this statement, the code is written like we have two variables that we are using, I and f. The value of f is initialized to 1, and then there is a for loop. The for loop runs from 2 to x, and it multiplies every value of I with the f or with the previous value of f. Okay, so this way once the loop ends, it returns f. So if we write the 3-headed code for this, so we are starting from f equals to 1. Okay, declaration statement, we are ignoring the declaration statement, we are writing the 3-headed codes from f equals to 1. So f equals to 1 is the first 3-headed code statement. Then for loop, I equals to 2, the initialization statement. This is the second line of the statement in the 3-headed code. And if the condition which is given is not true, so we'll be going to the last statement. Okay, so if I is less than or equal to x, the condition is true. If I is greater than x, it means the condition is not true. So the third line says if I is greater than x, it means if the condition is not true, condition is false. So we are going to some statement. By the backpatching, we will be writing the statement number. So here you can see that 9 statements are written and the last statement is 9. So that's why we have written if I is greater than x, it means the condition is false. You have to go to 9 number statement. According to the loop, the condition is false. Now if I is not greater than x and I is less than or equal to x, from 3 we will automatically move to 4 statement number 4. So if you are at statement number 4, it will be performing f equals to f multiplied with I. So f equals to f multiplied with I is performed in 2 steps. First is f multiplied with I is stored in some t1 temporary variable, and then the assignment of t1 to f in the 5th statement. After this, the loop, since this is the for loop, so increment part I plus plus. For this again we need to write 2 statements. First I plus 1 is performed, which is stored in some temporary variable t2, and then finally the incremented value of I will be stored, which is there in the t2, will now be stored in I again. So for I plus plus we have 6 and 7 number line. After this we will again have to go to the condition, and if the condition is true, we will be again executing the same number of statements. So 8 is saying go to 3. So go to 3 means it's an unconditional jump. So we are going to 3 and again checking the condition. Fine. So these are the 3 address code statements for the factorial function. Okay. So having found this, we need to find out the basic blocks, because in this 3 address code, this is the job of the intermediate code generation phase. Now we are entering into the code optimization phase, which will identify the basic blocks, and then after the basic block, it will be identifying the loop. Now about finding out the leaders, because for finding out the basic block, we will have to find out the leaders. We have 3 rules for finding out the leaders. We will be employing all these 3 rules for finding out the leader in the 3 address code written in for the factorial function. So the first statement is a leader. So statement number 1 is a leader, and then target of any conditional or unconditional jump is a leader. So if you see the statement number 3, which is saying us to go to 9 number statement, so 9 number becomes the leader. So up till now we have 1 and 9 as a leader. 1 because it was the first statement, and 9 because this is the target of a conditional jump. Okay. Acha, conditional any target of the unconditional jump is also leader. So unconditional jump is at statement number 8. It is saying us to go to 3. So 3 also becomes the leader. Okay. The third rule says that any statement that follows the conditional jump or unconditional jump is also a leader. So 3 is a conditional, 3 is a condition. So 4 will become a leader. Okay, similarly 8 is a unconditional jump, so 9 will become a leader. In fact, 9 was already a leader. Okay, so the rule, according to the rule, we have again said the same thing. Okay, so now we have 4 leaders here. F equals to 1, the first statement, the third statement, the fourth statement, and ninth statement. So by this we have found the leaders. And now, having found the leaders, we will now be attempting to find the basic block. Now see, to find out the basic block, the rule says that a basic block will start from one leader to the next leader, but excluding the next leader. So now if you see the statement, statement number 1 is a leader, statement number 3 is a leader, statement number 4 is a leader, statement number 9 is a leader. So statement number 1 to 3 can be a basic block, but excluding 3. It means statement number 1 to 2 is a basic block. So we have given it a name B1. So on the left hand side you can see the code, and on the right hand side you can see the basic block that we have formed. So the first basic block is B1, 1 to 2. Fine. The same rule continues. So starting from the 3, but excluding 4, because 3 is a leader, 4 is a leader. So we will start the leaders from 3, but excluding 4, it will be a basic block. So statement number 3 is the second basic block for us. Then again starting from 4 to 9, but excluding 9, it means 4 to 8 is the third basic block. We have given it a name B3. And then the last one, it has only one statement, so it will also be a basic block 4. So this way we have found the basic block. Now having found the basic block, we will now be finding out the control flow graph, program flow graph. Now the basic block is there on the left hand side. Depending on the statements written in the basic blocks, we will be finding out the program flow graph, and then we will be doing the control flow analysis. Okay, one thing more to be noticed, that if we have, let's say, 4 leaders, then the number of basic blocks will also be 4. Okay, so this can be remembered as a rule. If we have one basic block, if we have 4 leaders, then the number of basic blocks will also be 4. So here from B1 block we can switch to the B2 block unconditionally. After the statement number 2, the statement number 3 will be executed. So left hand side, we are looking at the left hand side statements, and then we are doing the we are assigning the arrows for the program flow graph. So from B1 block we can go to B2 block directly without checking any condition. Now from B2 block, which is a statement, we may either go to the B3 block or we may go to B4 block. So if the condition I is greater than true, we have to move to 9, that means B4 block. But if the condition is not true, we have to go to the B3 block. So one flow is from B2 to B3 and one flow is from B2 to B4, depending on the condition. Now if you see the B3 and the 8th number statement in B3, it is saying to go to 3. So 3 is what? It's a B2. 3 is a basic block B2. So from B3 we are moving to B2 block. So now if we do the control flow analysis here, in the control flow analysis from B2 to B3 to B2, it's a cycle. So if we are detecting a cycle, it actually is a loop. So that's what our target was. We were doing the control flow analysis with the help of the program flow graph to find out the loop, because we have removed all the loops in the intermediate code generation phase. Once we have entered the code optimization phase, we will have to do the loop optimizations. Now for doing the loop optimizations, we need to identify the loops. How can the loops be identified? The loops can be identified with the help of the basic blocks and the program flow graph by doing the control flow analysis. Fine. So we can find out the basic block. We can create a program flow graph, and then we can perform the control flow analysis just to find out what are the loops. In fact, if we in the control flow analysis, if we find a cycle, if we detect a cycle, we can say that this is the loop in the original program. Thank you.